participants. We are holding this session in middle of the monsoon, where from news reports we find that entire India is flooded, all rivers are overflowing, millions and millions of cubic meters of water is getting wasted into the sea. Ever since I started attending such seminars, both within India as well as out of India, one slide used to be very common in almost all the presentations. You must have come across with that slide as well. And that is about water facts, facts about water. And it's no point, we can again repeat it, and that is a hard fact that 97% of the water is in sea, it is saline water, 2% is locked in glaciers, less than 1% is only available for human consumption. Out of that 1%, again about 0.5% is underground aquifers or humidity in the atmosphere, and hardly 0.4 to 0.5% of water only is available for mankind. When we say 0.4% of water is available for mankind, this includes three major consumers. One is agricultural needs, second is municipal requirements, and third, of course, the industrial requirements. The industrial requirements are quite less as compared to the number one and number two requirements, that is agriculture and municipal requirements. Ever since Earth has formed some millions and millions of years ago, not a single drop of water has depleted nor got added on Earth's surface. That's a hard fact. Water cannot be produced, it itself is a raw material. So where is the problem? We say there is plenty of water, not a single drop to drink. So where is the problem? Is the problem is availability or is it the problem of distribution? In my opinion, it's all the problem of distribution. Population densities have increased surrounding the industries or surrounding the financial hubs or new cities which are forming. Water sources remaining same, freshwater sources remaining same. So there is a huge supply-demand gap. I will not talk on agriculture water requirements. I salute our farmers. I feel that they are the best conservationists of water, and they don't waste water. There is a different theory about crop management, high water intensive crops versus low water intensive crops, so that they are special subject, and the specialists will talk about that. I come from industry, so I will have a managerial approach to see the problem of both municipal requirements, which is one of the bulk water requirements, and second, the industrial requirement. When it comes to municipal requirements, about 60% of the water in all our A class, B class and C class cities, hundreds of those cities across India, 60% of the municipal water consumption, the water ends up into a sewer network. So, and that treated sewage water is getting wasted, almost wasted. There are only few cities where some policy framework is there and where some network is there for consumption, but that also is a very, very small fraction. We cannot count when we talk about the requirements or the percentages all over India. The figures are very dismal. And what is the problem actually? When I was at Vizag Steel Plant some 25 years back, I got entire township sewage got collected, treated sewage of course, and through a tertiary treatment plant that water was taken to the rolling mills, and very effectively that water was utilized there. So technology wise, absolutely no problem. Water technologies are quite mature. The whole problem is about policy frameworks, implementation and achieving. So there is a huge gap between what we say or what we talk and what we implement. And there's still a bigger gap between what we implement and what we achieve. So unless these gaps are filled, the problem is not going to solve. As far as water conservation is required, I feel there's enough awareness about water conservation, like Swachh Bharat Mission, where you get embarrassed even you throw a small piece of paper out of your car. So that is the awareness which got generated. So water also, that type of awareness is prevailing in India. I don't think people deliberately waste water. There may be some leakages, etc. Industries as compared to 10 years back or 20 years back position and as on today, majority of the industries are recycling their water, and that recycled water is being converted either into boiler pit grade or made up to the cooling towers. The whole problem is the implementation, as I told. Then what is the issue? There are 4 factors why this municipal sewer is getting wasted, which is very, very precious water. An equivalent amount of water, fresh water from rivers, can be diverted to the drinking water requirements if the 60% is tapped. And you can convert this water. I strongly believe that you can convert any water to any desired level. Treatment technologies are available, best technologies are available. Treatment technologies are matured enough. There is no question about doubting about the technology. You can convert it, the sewers can be converted into drinking water. There is absolutely no issue. Then what is the issue? In my opinion, there are 4 factors. 1, sewage is getting wasted. Number 1 requirement, if you want to install a tertiary treatment plant to make it better water for utilization either by industry as per municipal or for any other purposes, or even for the drinking water purpose like what Singapore has done. So a treatment plant has to be installed downstream of the STP. Secondary treated water has to be treated to tertiary level. So there is a land requirement. So there is a capex requirement. So the land will be either at the downstream of the STP or the land will be at the end user side, which will be say roughly 15 to 30 kilometers in a typical city. That will be the distance. The second and the foremost requirement is who will bear the capex for installing the tertiary treatment plant. Again, there are 4 or 5 major players. One is municipal corporation, the other is the state industrial development corporation, third is government, fourth is the end user, and fifth maybe in some cases a third party who has interest to install the plant and treat it and supply you water at a cost. But who will install? That policy framework is grossly missing. There is utter confusion. And there are states who have promulgated this ordinance about use of the secondary treated sewage within a radius of 50 kilometers. But where is the implementation? Implementation is lacking only on account of the lack of a policy framework. Third important factor is a pipeline has to be laid from the treatment plant to the end user. Say about 15 to 30 kilometers of pipeline. So there is a capex for that pipeline. But above that capex, more important factor is ROE, right of way. Who will lay the pipeline? Who will get the right of way? If a consumer goes for getting the right of way, there are n number of problems. It's impossible for him to lay the pipeline. Fourth thing is the pricing mechanism. If you want to convert the secondary treated water to a tertiary grade through an RO, say ultrafiltration and RO, to a level of TDS of say 100 ppm, which is best utilized for any, required for any industry or any municipal corporation or even for hospitals or schools or anybody, then there is a capex to install that. If I talk about OPEX and capex of this tertiary treatment plant, the OPEX will be hardly rupees 12 to 13 rupees, depending of course on the power tariff prevailing in that particular state. But still it will not be more than 12 to 13 rupees. Capex wise, it will not be more than 15 to 17 rupees per cubic meter on a life cycle cost basis for a 15 years period. So OPEX and capex on a life cycle cost basis, it comes to 30 rupees, which is quite less than your fresh water from which you are drawing from the river. Fresh water is being charged at about 30 to 35 rupees with an escalation of 10% year-on-year basis. So if you talk of freshwater requirement on a life cycle basis, the freshwater cost prices are roughly around 75 to 80 rupees. It will end up that way for a 15 period of time on a life cycle basis to have apple-to-apple comparison. The treated sewage, which is costing you at 30 rupees, freshwater is at 75 rupees. But if you start charging the secondary treated water at an exorbitant rate, then the whole exercise is false. There are states who say that you pay me secondary treated water which otherwise is going to waste at a zero cost. If that water is charged at 10 to 15 rupees per cubic meter, that also 10% escalation year on year basis then you end up with a life cycle cost of about 80 rupees per cubic meter for this treated sewage. So where is the attraction for any end user to tap this water or go for it? And that is one of the main reason out of these 5 factors. These 5 factors are the main reason that not a single drop is getting utilized. And the entire treated sewage is going to waste, either to river or to a creek or to a sea. Policy frameworks are there, implementations are grossly missing. And these are the 5 factors why this implementation is not being done. At the same time, if a bulk consumer, be it anybody, be it a municipal corporation, be it a hospital or industry, a software park, if they want water, and if you charge them at 80 rupees this municipal treated water, the seawater desalination is a far better option for anybody. Seawater desalination on a life cycle basis or 15 years life cycle cost basis will cost you not more than 50 to 55 rupees. Chennai it is being sold at some 48 rupees, I think, if I am not wrong, but that plant was installed about 10 years back. And desalination is picking up in India. Chennai has shown the door. The Chennai plant capacities are being tripled. Recently 400 MLD plant inquiries have been floated. Jamnagar, as I told, we are producing 20,000 cubic meters per day or 500 MLD per day desalinated water. Gujarat, couple of orders we have seen recently. So desalination is the future. How you produce, how you distribute, what is the business model, what is the financial model, that of course have to be worked out very seriously. So when desalinated water is available at 50 rupees, freshwater, river water is available at 70 or 75 rupees on life cycle basis. If you make available the tertiary treated sewage at 80 rupees, who is going to buy it? Definitely there will not be any buyer for that, and that is what is exactly happening. That is the ground reality. If that water, like seawater, which is at zero cost, if this tertiary secondary treated sewage is given at zero cost value, then it is a very, very attractive proposition. Even a third party, a businessman will come and install his plant and sell water to you at a rate of say 30 or 30 with his added profits at some 35 rupees or so, which will be still cheaper than your river water, which will be still cheaper than your seawater desalination. An equivalent amount of water can easily be diverted for your freshwater requirements, like mainly drinking water requirements. So this is one of the major area. I don't think that conservation, save a drop and all is going to work. Now people are very aware, and thus water conservation and all is not going to produce more water. You have to produce bulk water. You have to, demand is there, consumers are there. And Indian market is such a market that anything you bring from outside or within India, there is a buyer. So buyer-wise, absolutely no doubt. I don't have any doubt that you will not be able to sell this tertiary treated sewage, which I say can be treated to a desired level, including up to drinking water grade. Coming to desalination, desalination is definitely growing. Very cost-effective desalination plants are available. Earlier we installed thermal desalination at Jamnagar. We switched over to reverse osmosis. And reverse osmosis plants are quite matured, and energy consumptions, which used to be about 6 kWh per cubic meter, are now operating at 3.5 kWh per cubic meter. So that is the energy efficiency of this RO plant. They are quite matured, very cost effective. And we have a coastline of thousands of kilometers starting from Gandhidham in Gujarat, coming down up to Bombay, then V-shaped India map, then going up towards Karnataka, then Goa, then Tamil Nadu, Andhra Pradesh, and West Bengal. The thousands of kilometers of land sea coast is available. You have multiple options. Bullock cart desalination plant is possible. Container-based desalination is possible. Truck-mounted desalination is possible. This barge-mounted desalination is possible. Boat or ship-mounted desalination is possible. You can have a moving desalination plant which will be running in the coast and fill every village tank and move on to next village. Hundreds of options are there. What is missing is grossly missing is the proper policy. We talk of conservation, again I repeat, but conservation is not going to help you. You have to produce one quality of water to another quality, that is desired quality, which is drinking water. So desalination is the future. This recycling of treated sewage is the future. As far as industrial effluents are concerned, I already told majority of the industries are recycling, and even if they are not recycling, pollution control boards are very strict. And for every application, the condition is being put that you have to recycle entire your effluent. So we at Reliance take our cooling tower blowdown, boiler blowdown, DM plant effluents, treated effluents, and every drop is passed through a tertiary treatment plant. Our capacities of tertiary treatment plants are as high as 1000 to 2000 cubic meters per hour. I repeat, 1000 to 2000 cubic meters per hour, multiple plants. We recycle entire water to cooling tower or to a boiler feed applications. So technologies are available. What is missing is again policy framework, and future is the treated sewage as well as the desalinated water. Further, coming to new energy requirements, I am deep into new energy like hydrogen economies and ammonia economies. For generating hydrogen, you need solar power. You need power. So solar power is the virtue. For generating solar power, for generating hydrogen, you need solar power. For generating hydrogen, 1 ton of hydrogen, you need 10 tons of water. So it's a hydrogen generation, hydrogen economy is a highly water intensive economy, hydrogen or ammonia economy, both. Because from hydrogen you will produce ammonia and you will start exporting ammonia, green ammonia. And for generating hydrogen you need water, for generating hydrogen you need power. For generating solar or green power, you need PV solar panels, and for making PV solar panels, you need water. It's not that green what we talk of. For making PV solar panels, you need water. PV solar panels can be manufactured with that vapor technology, which requires very high grade DI water with almost a 20 resistivity of water. 20 kilo ohm centimeter resistivity or almost zero conductance of water which you want to wash your panels. For making those panels you need polysilicon, you need the glass factory, you need a ingot factory, etc. Yeah. So this almost at the end. So for making hydrogen again you need water. So for generating this hydrogen you need desalinated water. Because hydrogen you will be installing in the arid lands across the coast or in Gulf of in Kutch or at Rajasthan or at remote areas, and remote areas you don't have water. So that is another dimension to hydrogen economy. I think I have covered everything. Thanks. Any questions?
Thank you,
Thank you.